In this video, I'm going to discuss how we can find the distance from a point 2, 3, -1 to the coordinate planes and also to the axis like x-axis, y-axis, and z-axis. First of all, let's see if we can visualize the point 2, 3, -1. So if we were to add a point here, let's just see if we can put the coordinates 2, 3, -1. And let's check the box so that it appears so we can see the point. So how do we get to it? Imagine starting at the origin and then traveling along the x-axis 2. So we jump 2 along the x-axis. Then we're going to travel 3 along the y-axis, and finally we're going to drop down by 1, and that's where we get that point right there, right? You can see it. Okay, so first of all, what is the XY plane? So in the picture, you can see it as a yellow plane. This is where if you pick any point on the XY plane, on the yellow plane, the Z coordinate of that point is 0. So it shouldn't be too hard to realize that the equation of the XY plane is Z equals 0. Similarly, the equation of the xz plane would be y equals 0. You can see how you can tell that by just thinking about which variable is missing. So xz plane would be the magenta plane, okay? And then the yz plane, finally, that would be the green plane. So that would be where x equals 0. So any point on the green plane has x equals 0. Now, we want to find the distance. So imagine that I'm trying to figure out the distance from this point to the yellow plane. So you should intuitively understand that when we were at 2, 3, 0, right here, we just had to drop 1 unit down. So to find our distance, the distance back to the xy plane, we just need to take the z coordinate, and obviously the distance cannot be negative. So even though we're going down, not up, the distance to the xy plane will be the same. So that will be 1. So basically what you're doing is you're taking absolute value of -1 and you're making it equal to 1, and that's the distance to the xy plane. Now, very similar to that, if I want to find the distance to the xz plane, this is where I'm looking at the y coordinate of the point. So to get to xz plane, which is the magenta, I would have to travel 3, which should be pretty clear, right? Or if I went from here to the magenta, I would have to travel by absolute value of 3, which is actually just equal to 3. Okay, finally to the YZ plane, which is the green plane, you would just have to travel 2 along the x-axis. So you will have to see it how you get there to the green plane. But see if I can rotate it. But yeah, you're going to be traveling 2 units, right? So whatever is the absolute value of 2, that's going to be your distance. Okay, now the x-axis, y-axis, and z-axis are a little bit more tricky. So what can be shown is that what you need to do is take your point 2, 3, -1 and find the projection of that point to the x-axis. In other words, find the point on the x-axis that is as close as possible to the point 2, 3, -1. So that point, the way to figure that out is to basically, because on the x-axis, the x is not 0, but y and z are 0. So you're going to just put 2, 0, 0. That's going to be your projection to the x-axis. So let me add another point. And then I'm going to say that that's 2, 0, 0. Okay. So this is the point on the x-axis. And now I just have to find the distance between them. And you can do that using the distance formula. So let me remind you how the distance formula works. So you're going to take square root, and then you're going to subtract x coordinate from x coordinate. So you're going to get 2 minus 2, and then you square that. Well, that's just going to be 0. 2 minus 2. Okay, plus. Then you're going to take 0 minus 3, square that, and then plus 0 minus -1, square that, and take the square root of all of that. So let's see if we can go to the calculator and see if we can compute what we got here. All right, so we're going to put, and I'll just compute what's inside. So 2 minus 2 squared is obviously going to be 0, plus 0 minus 3 squared. Okay, that's just going to be 9. And then plus 0 minus minus 1. So that's just going to be 1 squared. Square that. And that's 10. Okay, So the answer, the distance to the x-axis is just going to be square root of 10. Now, if we want the distance to the y-axis, what we're going to do is now take the projection of that point to the y-axis. So now let me change to the y-axis. So z should also be 0. There you go. All right. So this point right here, 0, 3, 0. That's the point that you want to find the distance to. So how would you do that? So that should be pretty straightforward. So you're just going to subtract the coordinates. So 0 minus 2 squared plus 3 minus 3 squared plus 0 subtract -1 and then square that. So that's going to be 5. And that's what's under the root. So then the final answer would be square root of 5. Okay, finally, to find the distance to the z-axis, the point on the z-axis will be 0, 0, -1, right? So looking at the plot over here, I'm just going to make 0, 0, -1 right here. And you can see that point, right, on the z-axis. What you're trying to do is find the distance from your point to the point 0, 0, -1. So let's see if we can compute the distance using the distance formula. So take 0, subtract 2, square that, plus 0, subtract 3, square that, plus -1, subtract -1, which is just going to be 0, square that. So this is going to be square root of 13.